just to comment on your statement about taking cutting-edge science with caution. Let me give you two interesting anecdotes. When I was a graduate student in physics over 40 years ago, I sat in at the beginning of a course taught by Professor T.D. Lee at Columbia. And he asked at the very beginning of the course, it's on theory of elementary particles, how many of the graduate students were studying theory and how many were going to be getting their PhD in experiment. And he said the reason he asked is he thought his course would be most valuable to the students whose thesis was going to be on experiment, and for the following reason. He said if you try to learn theory, the subject I'm going to teach you, by reading papers in journals, it'll be extremely inefficient, because he said 90% of the papers published are not true, and of the 10% that are true, 60% are obscure. So he said, if you take my course though, I'll teach you what's true and I'll teach you in a concise way. So he had a very low opinion of his field. He was a Nobel laureate. He had won the Nobel Prize when he was 30, and that was his view of the field. Then when I was doing postdoctoral work on visual perception in psychology, I was at a conference and just coincidentally sat at the table of a professor from Yale Medical School who won an award that year for research he had done on ophthalmology and glaucoma. And we just struck up a conversation, and I told him how disappointed I was in many of the papers I had read on perception. And I questioned the value of a lot of them, and he, without my prompting, said, well, in his own field, he thought, same percentage, 90% of the papers, 90% of the research that was done was junk. And he attributed it to the fact that he thought people learn certain skills and techniques to do experiments as graduate students, and then that knowledge becomes frozen. And as they work in research, they apply the methodologies they learned inappropriately, even if it wasn't relevant to answering the particular question they were interested in. The key was that here were two very prominent men in two different fields. And when I was active in science, I heard both of them come up with the same estimate that, in their view, 90% of the papers published in their own field were junk. I just thought you'd find that interesting. It's so that here were experts in the field themselves skeptical of a lot of what was published within their field.
Thanks, Evan. That's helpful, and I've had some similar experiences when talking to people who are prominent in philosophy or history of philosophy and some other fields, and also in judging works within areas where I think I have some expertise in philosophy.
Jean.
I have a question about something that you didn't really talk about in how do you validate the expert, or what the expert needs to give to you and what you need to do to validate what you get, which is the role of doing your own integration of what the doctor says or the expert says. And I think there's two things. One is I think that the expert, in doing the reduction, can specifically point out things that you can look at in your own context of knowledge. A big problem in gaining knowledge is sometimes knowing where to look and what differentiation to make. And I think that's what we get from a lot of Ayn Rand's articles, is she puts one thing next to the other so that you can now form the concept, which never would have occurred to you to do, but when it's put in front of you, you can do it. But then there's some work for you to then make those observations and make those connections. If it's helpful, I have an example, but I don't know.
Yeah, give me an example.
So I had a big problem with headaches about a year ago. And I saw, my doctor, and I saw two different neurologists. And I kind of got authority advice from them about what I was supposed to do, and it didn't seem to be working. It didn't make sense. And fortunately, someone suggested I read this book by a neurologist from, I can't remember, the college in Maryland, I'm losing.
Johns Hopkins?
Yes, that's right, Johns Hopkins. So, a reputable person who actually explained an entire mechanism for what would create all the symptoms, gave an argument which, the doctor says, oh, you should stop having caffeine, oh, you should stop, hormones, various things. none of which made sense to me because there'd been no change in that. But in this book, he explained a mechanism whereby there are, 15 factors that can create headaches, and that why this could happen, and that in fact, after reading the book, I realized it was part of a pattern of 10 years. It wasn't just a sudden new thing. So he explained an entire mechanism, recommended what to do and what to look for. And as a result of reading that book, I was actually able to differentiate the headaches I was getting, and I learn. It's like 15 triggers, and you take them all out of your life, and then you can put them in one at a time and see if you get headaches. And it worked. It's Mill's methods, and it worked perfectly, and I don't really have a problem with it anymore. But until I got the full explanation and what I needed to do to see if it made sense in my own symptoms, I was kind of at a loss.
I did say, I think, that one needs both to reduce the doctor's conclusions to oneself, which of course means bringing it back to one's own experience, and that one needs to integrate his conclusions into one's context of knowledge. So I don't think, I think I've said what you want me to say here. The thing I want to add, though, is that the way in which one does this reduction and integration with an expert's testimony, with a doctor's advice, isn't fully independent of the expert, of the doctor and his context of knowledge. Because your own reduction and your own integration is still relying on his setting of the context, and you don't have all the information needed to independently check that. For example, you point out how Ayn Rand helped us to make all these differentiations within our own experience, and how that put us in a position to form certain concepts, maybe the concept intrinsicist, for example. But we should keep in mind that there are lots of other philosophers who, by setting different contexts, prompted people to form other concepts, invalid ones, extremism, duty, white privilege. Not all of these are philosophers, but philosophers, politicians, whomever. So we really need to check that context for ourselves, the context that's set by somebody who's giving us advice. And in philosophy, I think we're all in an equally good position to do that checking. We all have the general context of knowledge required for philosophical thinking. But in the special sciences, that's not true. There's a lot of specialized knowledge that has to be built up that then provides the context for thinking about particular cases. And we have to rely on the experts for that context in a lot of cases. Now, with regard to the example of the headache book, it sounds like the book gave you more of what I was saying that an expert should give you than did the doctors you saw, and it sounds like you used it well. The book explained more of the reasoning behind the recommendations, and it tied it more into a kind of understanding of the situation than you say the doctors did. That's, not necessarily a slight on the doctors you visited. The book has a lot more time to do the explaining than the doctors would. The other thing that's relevant to the book example, I think, is that the book gave you what we might call a protocol. The doctor, when you see him, has steps he's going through to explore and check out various hypotheses and make different provisional and then stronger recommendations along the way as he goes. And it's sounding like the book you described manualized all of that, so that you can do a lot of that work yourself. It's like when an expert makes a manual or a script for someone to follow on an IT helpline. Did you turn the computer off and turn it on? Are you sure it's plugged in? Okay, well, have you rebooted? Have you done this and that? And those kinds of scripts can be useful. I mean, your ability to implement the protocol yourself won't be as good as the experts, who will have more context to bear on evaluating the observations and might go off script in certain cases because he'll notice that it's a different situation. But these kinds of manualized versions of things are useful because we can't all be experts, and those of us who aren't often have a lot more time to devote to our particular problem. So these kinds of books are valuable. And what's the epistemology of this? Well, in any case, I mean, if there was evidence going in, and you say there was, it seems right, that this author knew what he was talking about the field. And then if the book explains why a certain type of procedure would let you isolate and eliminate the causes of your headaches, and you followed this procedure and the headaches went away, whereas they'd been persistent up until that point over a long period, then I'd say that all of that gives you probability that you whatever you came up with is the cause of the headache and that you've eliminated it. And I guess all of that also gives you possibility about any more theoretical claims that might have been in the book that's behind that. Whether it does or not depends on a lot of details of the case, and we'd have to get into that.
My question was, this didn't seem to be this kind of thing. You warned us against, I forget what your exact term was, but personal experience.
Uh-huh.
And it seems to me that personal experience is an important thing to bring in here on both sides of the equation. It's not all the other things you talked about are important, but I think this is an additional thing. And I'm curious why you didn't bring it in.
I think I listed it under...
I think you said it in a different way, Greg.
Yeah. Go ahead, Jeff.
You were talking about personal experience in the context of, I walk outside, it's really hot today. That certainly is global warming in action. That's a very isolated...
But I also did give self-medical experimentation as an example of personal experience. And with respect to both of them and to some of the other things I cited as possible problems, what I tried to do, but I don't think I highlighted it enough, is said there's an illegitimate way to use this, and then said, now what is the appropriate way to use it?
Exactly. Right.
And I think when one's dealing with a kind of general claim, the appropriate way to do it is to try to integrate it into the knowledge that the expert's giving you, but to do it in a way that asks the experts in the field how to integrate it. So, particularly, I mean that where there seems to be contradictions. So not just find a contradiction and say, well, to hell with what the expert said, but rather raise that to the expert. How does that mesh with this? Because the expert just can't have given you every possible qualification to the things he's told you, or every possible bit of context that might be needed to relate what he said to every real or seeming bit of counter-evidence. So it's unfair and more importantly, unproductive to, in effect, play gotcha with an expert by pointing to something you've observed that doesn't seem to fit. What you need to do rather is to enlist his advice in seeing how that thing might fit, and then, of course, fit into the wider context he's provided. And then, of course, ultimately you go home and in your own time you evaluate that, and if it doesn't make sense, you start to discount him. Incidentally, I've been talking about integrating your personal experience into the context that the expert's providing, where his context is what's wider. And, that might seem backwards. In a way, it is backwards. Ultimately, what we need to do is integrate what the expert provides into our own full context of knowledge, so that your own context is the wider whole here, and what the expert brings is something that's specialized and narrow by comparison. But what I've been talking about is the more proximate respect in which the expert's knowledge serves as the wider context. So what I mean is just the expert knows more about headaches than you do. And even wider than that, he knows more about medicine and the human body than you do. So he has a much wider context to bring to bear on what you've observed about your own headaches, say that they happen in the evening or after you've eaten this. So he can take that and put that into the context of his wider medical knowledge, give you advice. If you notice something that doesn't seem to fit with that, you bring that to him and ask him what to make of it, and he gives you an explanation. And then ultimately, of course, you have to take all of that, and bring that into the context of your whole knowledge. And, you're always evaluating both his specific claims and your reasons to take him seriously as an expert. Another aspect of the issue of relying on personal experience in medicine, an aspect that doesn't come up in cases like judging climate science or evolution or theories in physics, is that medicine is an applied science. The general knowledge about what causes or cures various ailments is developed by a scientific methodology in which the personal experience of the individuals involved plays a certain specific prescribed role. But then, of course, this knowledge needs to be applied to individual cases by individual doctors and patients. And of course, when doing this, you have to judge by your own direct experience whether, for example, your headaches improved after the treatment. There's no other way to judge that. And, of course, you have to infer from that judgment, along with other background knowledge, whether the treatment caused the improvement. So, I certainly don't mean to be warning against relying on personal experience in that way. There's nothing else to rely on there. But I do want to stress that it's very easy to make mistakes in such judgments, that it's a lot easier than I think most people realize. There are very strong placebo and nocebo effects, and confirmation bias is really strong. So if you start to suspect that a certain thing is causing your headaches or your indigestion, then you'll be sensitized to any incidents in your experience that confirm the hypothesis, and you won't be similarly sensitized to counter-evidence unless you make a real effort to. So it becomes easy to think that your experience taken as a whole confirms a hypothesis, when in fact your experience taken as a whole does not. Moreover, most ailments go away, or at least wax and wane, on their own eventually. So if you're trying a whole bunch of different remedies, one of them will be the one you happen to be trying when you got better, and then it'll be easy to assume that that's the cause. And then, of course, the confirmation bias can kick in as you evaluate that. So because of all these factors, I think people often think that they know a certain thing caused or cured a symptom of theirs, when in fact this is only at the level of possibility, or in some cases when it's only arbitrary. I mean, think of all the people who swear by homeopathy or Reiki or other face healers. These are people who think that they have first-hand experience that proves that these treatments work. But if one understands the science involved, I think one can be certain that they cannot work, and therefore that they did not work in the cases of these specific patients. So the moral of that is it's easy to be fooled, and it's hard to be certain based on personal experience about the specific causes of many of our own ailments. But you don't usually need to be certain. With some common sense thinking precautions of the sort you can find on the Science-Based Medicine site, and just by sensitizing yourself to these issues, it's not that hard to develop the mental hygiene needed and to be rational and confident in your judgments of probability in these cases. And that's enough to act on. In some cases, even just possibility is enough to act on, and possibility is much easier to achieve. So if you find that you regularly experience some symptom only after eating a food, and it's not a food you often eat, that can raise it to the level of possibility that that food is a cause of the symptom in you. And if it's not a food you love, then it's perfectly reasonable to avoid the food. Although, let me just add one particular thing. I think when people do self-experiments on things like diet and such, they're often unaware of the kinds of effects that would have to be controlled for if you were doing this in a proper study. And among those effects are what you've been eating recently. So there are all of these kinds of protocols people go on where they cut out 100 foods for a month, and then they reintroduce some of the foods a month later, and then some 2 months later, and then they get sick when they reintroduce the third one. They think, well, that one's been causing all of my problems for the last 30 years. But relevant to what effects you're going to have from doing something or eating something is also what you've been doing before that. So if, for example, and this example comes from Karen, you've been a vegetarian for 10 years, and then you eat a steak, and you feel a little queasy after eating the steak, that doesn't show that steak is bad for you and you are right to be the It might be that your relevant enzymes for meat regulation or whatever have regulated down in the 10 years of disuse, and after a couple of more steaks you'll be fine. And I think a lot of people, particularly with these kinds of allergy and inflammation diet things that people are on, do these kinds of self-experiments that they think establish a lot more than they possibly could in their own cases. That's not to say that it's unreasonable to try these sorts of protocols. I mean, I know a number of people who've done it with what I think is a very sensible attitude. They've had some medical issue that they were unable to resolve by other routes. Someone recommended a certain book or program to them. They tried it, and they arrived at some change in their diet or routine that seems to have worked. They're not certain that the relevant change did the trick, and they don't claim any deep insight into the issue, but they regard it as probable, or in some cases just possible, that the relevant regimen is helping them. And given their context of knowledge and values, the most reasonable course for them is to stick with it.
What's the role in general of something like a causal mechanism, which I think was one of the implications maybe of Gene's question, is if you know that something happened and like you changed your diet in a certain way in the example you gave, how much can you judge your confidence, the probability of that you know what is good for you or what is bad for you or what is causing what, if you do not have a specific causal mechanism in mind. Like I'm thinking, in the case of a steak, you said, well, it was coincident that I started eating the steak, but without knowing the causal chain, you don't know that the steak itself is bad for you. Or another case that comes to mind is, I saw an article in one popular magazine, and it was arguing that sunscreens are actually bad for you. And the argument was, it showed the increase in the use of sunscreens in the United States coincided with a substantial increase in skin cancer. And how you will interpret this depends on your knowledge of the causal mechanisms of how skin cancer comes about.
So let me start with the steak case, because I think we might be talking at cross purposes with it. So what I had in mind with the steak case wasn't the case of where someone who's been a vegetarian for a long time eats a steak and coincidentally gets nauseous, although that could certainly happen. I was thinking of a case where we might even think the steak caused the nausea, but it caused it not because always steak would cause nausea, but where a specialized diet would change one's gut in such a way that it would take some time to get reacclimated together. I suggest that. But there are also lots of cases, and this was what was going on, I was saying, to the possibility in some of the headache examples, where your spell of headaches would have gone away after a month anyway, and you were desperately trying different things all months to get them away. You were on whichever one of the things you were up to at the time that they would have gone away otherwise, you attribute causation. Now, to what extent does it matter that you have a causal account of how this thing could cause this effect?
Well, and evidence that is in fact causal.
Well, that we need evidence for the causal mechanism is really the key point here. We have to keep in mind that there are just all sorts of spurious causal theories that purport to give mechanisms for real or alleged phenomena. Theories that aren't at all well supported. There was the four humors theory in the history of Western medicine, which was largely arbitrary. And then there are the various non-Western medical theories that remain popular in some circles. As far as I can tell, these theories are also wholly arbitrary. They are alleged explanations for things like the success of acupuncture, where it's dubious that there are any successes to acupuncture. Then there are theories that aren't arbitrary as far as the layperson can see. They're not kind of clearly mystical like chi or meridians or whatever, but that still may not be on a firm footing. There may not be the evidence for them that people take it to be. So, for example, there are the mainstream nutritional views about the role of dietary fat that have come under a lot of scrutiny recently. And then there are the various alternative medical theories about inflammation and the like, which I don't know whether there is any evidence for or how good that evidence is. So the point of all of this is that these are all theories that claim to establish detailed causal knowledge, and they don't, or it's hard to know whether they do. It's hard to establish causal knowledge about complex systems like the human body. So when we're asked about the role of a causal mechanism in evaluating a claim, it depends wholly on whether we're talking about a causal mechanism that we know to exist and to be operative, antecedent to this claim coming up for our evaluation, or at least whether we have strong reason based on good evidence to believe that the mechanism exists prior to considering the claim in question. If we do have that reason, of course we're going to consider the new claim in light of it, because that's just integrating it into the context of knowledge we already have. The alternative possibility is that the existence of the causal mechanism is part of the new account that we're now first evaluating. And since causal mechanisms are hard to establish, that will often make the claim harder to establish objectively. So now you bring up the example of an article about a study that said there was some correlation between sunscreen use and skin cancer. The first thing to think about in any case like this is whether the article is worth taking seriously, because there's, a lot of really bad popular science writing. But supposing that it's a credible source, or you think it's a credible source, and you follow up on it and you find that there is some such correlation or reason to think that there is one, then of course you're going to have to interpret that correlation in light of whatever scientific knowledge there is on the causes of skin cancer and I guess on the effects of sunscreen. I've heard some people worried about whether sunscreen blocks vitamin D production, but I don't know if there's anything to that. So in any case, if there's reason to think there's a real correlation, and if it's relevant to your values so that you need to know about it or want to know about it, it's something to evaluate in that context. And if you don't have that context of knowledge, it's something to raise with a doctor who knows what you need to think about what might be causing such a correlation, if there is one.
Could I suggest something?
Yeah.
People get these cancers when they get older. People who are now of the age where these cancers would show did not have sunscreen in their youth, such as me and other people I know who have them. And people live longer, so more people get skin cancer because they're not dead of something else.
That's part of what I think one would want to know in seeing if there's anything to this study in the first place. So if they're not controlling for the fact that people live longer, then then the study's out, so to speak. If they're just saying that sales of sunscreen correlate with people getting cancer, when the people getting cancer wouldn't have been the people using the sunscreen, right, because of the gap, then that's obvious. But that seems to me like such a blunder that I have a hard time believing that that's what someone published a study saying. So I would think if someone thought the study was newsworthy, giving them a certain benefit of the doubt, I'm guessing they were thinking that the populations that used sunscreen correlated with those same people's later getting cancer. But
no, I actually looked into this.
I think it's probably
is it really as bad as that?
It's much closer to what Harry
This raises a general point, which I know from some things I know from what Judy Berliner says about cancer reporting, because she works in that field. She says that whatever you read in the New York Times, LA Times, any newspaper on science reporting is wrong. Science news reporting in newspapers is either a year and a half out of date or just wrong.
This seems like a doubly boneheaded blunder. So it might be that that's what they're doing. Again, this is what I had in mind.
I picked this one because I think it is a very boneheaded blunder. Because I'm very prone to getting sunburns and things. I asked my doctor, what his and he sent me reams of information, and the gist of there were many important things that were overlooked, but the most important is that most of the photo-caused skin cancers take 30 or 40 years to develop. A fact that was entirely omitted from the article on the correlation. So as Harry said, the question isn't how much sunscreen are people buying today, it was how much were they using 30 or 40 years ago, which was, the article did not include that fact.
So then I was misunderstanding the question, because it sounded like you were asking where one has evidence that one thinks is good, that there is some kind of correlation here, then how does one decide what direction the correlation goes in, or something like that?
Yeah, I was more asking how, if you have an apparent correlation, how important is it to understand a causal mechanism and to understand the evidence for that causal mechanism? Because judging this report hinges a lot on things like, how does skin cancer develop? And unless you know the answer to that, you're at sea on this report.
Well, there are causal mechanisms and causal mechanisms. I mean, causal mechanisms exist at different levels of detail and require different amounts of knowledge to ascertain. So we can know just based on normal life experience and our observations of other people, without any specialized medical research, we can know that what happens to our skin affects our skin. I mean, you can cut your skin and, you see what happens to it, and and how it heals and goes through stages. And likewise, you can burn your skin on a stove and see later a boil form there, or you can get a sunburn and it looks different the next day, and so forth. So if you spend a day out in the sun with or without sunscreen, and other people do this, I think here's a case where you can observe the effects based on personal experience, as we were discussing earlier. So given that background knowledge, which again it's causal knowledge, but it's not medical research. Given that background knowledge, if some study had found that people who apply sunscreen to their own skin later get skin cancer at a greater rate or a lower rate, then the common sense background causal knowledge would be sufficient context to think that there might be something to the study, and you'd be in a position to pose and explore various hypotheses about what the causation is here. Does the sunscreen itself increase the risk of cancer somehow? Or maybe people who are already at higher risk for cancer were using sunscreen more, and the sunscreen just doesn't help enough to offset the greater risk. Or maybe the sunscreen doesn't protect from cancer-causing rays, and yet people who use it get more sun exposure than other people. So those are the sorts of hypotheses that would come up in that kind of a context, and you'd need to rely on your knowledge of how sunscreen works and what causes cancer to see if there's anything to any of those hypotheses. So that's the kind of case I was imagining we were talking about. But if there's just a correlation found between some people's getting skin cancer and other people's wearing sunscreen, that's, one of these arbitrary correlations, like the number of periods in the New York Times and how many people die in Belgium, that there are just going to be random correlations. And there's no reason to suppose, and you don't need any medical knowledge to know that there's no reason to suppose that some people's using sunscreen can be the cause of other people's getting skin cancer. I mean, if there's any causal connection there, it would have to be the other way around. The increased cancer rate in the older generation could be causing younger people to take preventative measures, including wearing sunscreen.
I think it's important to differentiate proving something in medicine and understanding at a very detailed level the cause. And let me give an example. When it was discovered that the reason British sailors got scurvy, that the cure for scurvy was for them to eat limes, hence limeys or lemons, that at that time it wasn't as if the particular vitamin was, that the scientific research was at the level of, we know this vitamin is necessary for the following metabolical processes, and if you don't have that vitamin, you will get this disease. Rather, it was they had enough knowledge to know, I think even prove, that certain foods were necessary to be consumed to avoid the disease. So I think it's really important to keep separate. Is it known that X is a necessary condition to avoid a disease, or the reverse, X will always lead to the disease, versus do we understand at a cellular level the causal mechanism?
Yeah.
And I think that, another example was smoking. I do think there was enough data by the 1950s to say this is really bad and it's almost certainly a cause of cancer, even if the exact molecular process wasn't understood. So I think it can work both ways. You can identify that X is necessary for health or X is horrible for health, be certain of it without it being a necessity that certainty require a very detailed biochemical process level of understanding.
That's right.
I agree with that, and I think it's important that we put it in terms of, we do understand that there's a cause-effect relationship here, but not at a biochemical level, rather than saying we know there's a correlation between this and we don't know if there's a causal relationship. Because the way this kind of knowledge works is that we know that, for example, things we put on our skin have effects on our skin and on what happens to our skin when light hits it. We know that things we eat and inhale have manifold effects on our body. And we know in very broad terms the types of effects they have. They make us gain or lose weight. They make us, our skin change color more or less when the sun hits it. They make us that, right? Those things we know in a kind of coarse way, that things applied to the skin can affect what happens when light hits the skin. Things eaten can affect us in different ways. Things ingested can affect us in many ways. And we know that there are lots of complicated cross processes involved in that, and that we don't know all the mechanisms by which all the specific mechanisms by which this happens. So I think that kind of causal knowledge is the sort of background causal knowledge that would be relevant here, rather than causal knowledge about the molecular type level causes of cancer, or the genetic causes of cancer. The kind of causal knowledge would be something like, things put on your skin affects what happens to your skin. Cancer is something that people tend to get when they're old. People tend to stay out in the sun longer when they're young. Those kinds of things are the kinds of reasoning that went into Harry's response, and that I think are the kinds of reasoning one needs to do, rather than, these very low-level mutations in the gene kind of causal reasoning. Some things we need that too, but here, I think that's
there's another, if I may, there's another factor. A real Mills method study would have taken identical twins or randomized cohorts, some of which used sunscreen, some of which didn't, and try and equate them in every other way, or randomize them among every other way, and see if there's a difference there. But did they do that?
Yeah. Although part of what's I talked about double-blind placebo-controlled studies being the gold standard in medicine. But part of what's relevant and why it's a gold standard rather than the absolute required for anything you do is that there are reasons why those kinds of studies are hard to conduct, particularly in certain areas. So, for example, it would be very hard to get people putting on placebo sunscreen, because you can get something that didn't have the substances in it, but they would still be putting something on their skin, and you might wonder if it felt enough like sunscreen that the people could get fooled, then there'd have to be some. So there might be good reasons why we couldn't do that kind of a study in this case, or the amount of time it would take to do it and the amount of money was prohibitive, but we could do a statistical study on percentages of something in a population, and maybe that was the best that could be done in this case. And there are often times when we need to make the best of the evidence available. So I wouldn't want to, say you charlatans to some scientists because there's some kind of study that would have been much more probative that they didn't do if there was a reason why they couldn't have done it, or it would have been hard for them to do it. And maybe this study, if it were not bad on other ground, would be a reason to think, boy, it's worth doing that other study, because we now raise to a level of possibility a kind of connection that otherwise wouldn't have been, and so wouldn't have been worth investing in.
And going back to the earlier discussion of status of knowledge and severity of consequences, if the available evidence says don't do X because all of the evidence indicates if you do X you'll likely get cancer, or you should do X to avoid getting a disease, even if there's not certainty, if there's preponderance of evidence and the consequences so severe, it's relevant to take that into account in how you act. You don't have to have certainty to say I'm not going to do certain things to avoid a terrible consequence, because it hasn't been proven to, certainty in my mind that I shouldn't do that.
Yeah. Let me use this occasion in the discussion to raise an issue that I was asked in the earlier version of this lecture, and that integrates to something from the first half I want to talk about too, which is what people call the precautionary principle. Mm-hmm. And you see this both in some kind of health issues comes up, and also in environmental considerations. And this is something like it's formulated in different ways. But if something really, really awful is possible, we should take, serious steps to avoid doing it because of how bad it is, even if it's at a very low level of probability. So I think this principle is basically a rationalization for a certain kind of recklessness. Because every time I've seen it applied, what it amounts to is there's some very, very small amount of evidence, maybe it's just above arbitrary, but maybe it's not, that some calamity might befall us. And because of that, we're going to invest a ton of resources and run a ton of other risks, which we're not even going to bother thinking about how much is being squandered and what those other risks are, in order to avoid this one thing that we're paranoid about because there's some minuscule chance that it's going to be a calamity. So I think what's called the precautionary principle is quite unreasonable. However, on the other hand, because I want to integrate this with the thing I agree with that Evan said, which is if something's not even certain but probable, and I would add, even if it's only possible, if it's a dire enough consequence, there's reason to stop doing it or to start doing things to prevent it. And this is one reason why I think the concept of possible, as not being anything I can think of, but as meeting a certain evidential threshold, is relevant. Once you think that something's possible, that it's a live thing that I'm providing for in my thinking, because I have enough evidence to justify it being that, then, not before then, but then, I think its severity becomes quite important, its value stakes become quite important in thinking about how much to allot for. So if it's arbitrary that smoking causes cancer, then I don't think one should start getting into the question of whether I should quit smoking if you smoke. I like it so much, how much of a cost would it be for me to give it up? But if it gets to the level where you think this is a possibility that smoking causes, even if you think it's not probable but a possibility, then I think it is worth saying, would it be worthwhile for me to give up smoking? How much do I like smoking? How much of a loss to my life would it be to give it up? And the right answer might be that it's not worth it for me to give it up. But I think once you elevate it in your head to the level of possibility, then that kind of thinking makes sense and is rational, and not prior to that.
The precautionary principle for the arbitrary assertions is essentially Pascal's wager.
Yeah, I think that's exactly right. But I think what gives it a certain plausibility is the fact that if something is rationally regarded as possible, then the value stakes for it do sometimes dictate spending a lot to avoid a certain bad possibility or in the hopes of a certain good possibility. And I think the arbitrary possible thing is really important for when that cost-benefit kind of analysis can start coming to effect, betting type reasoning, once it raises to the level of possibility.
When something raises to the level of possibility, that's telling you that you need to take some action.
Yeah.
With regard to which the action may simply be paying attention. It might be changing behavior with regard to that thing, but it might also be go find out more.
Yes, and I think most often is go find out more, or at least keep an eye on whether anything you're doing would be thwarted by it if it turned out to be true. Yeah.
I wonder if you would agree with this view of the arbitrary. We've been kind of sliding into the view that there's an evidentiary scale from 100% down to 0. And there's certain very small ranges where you're not sure to say, well, is this really far enough away from 0 to count as possible? And Andrew just said if it rises to the level of possible. And I've come to think, and I wonder if you agree, that the arbitrary is not on that scale at all. That the arbitrary means the dreamed up. And something like smoking causes cancer is not dreamed up. Even if you're bringing kind of harsh stuff into your lungs for hours and hours your whole life, it's certainly reasonable to consider, does that do something bad? It's not like something really arbitrary, like tomorrow morning when you wake up, there will be a hailstone the size of a golf ball that will hit you on your left shoulder. Why do I say it? I don't know.
Well, all right, so a few different thoughts here. One, I want to distinguish before we get into this two cases. So take John Smith, whoever it was, the early American settler that got into producing tobacco.
Rolfe.
John Rolfe?
Mm-hmm.
Okay. So back in the time of John Rolfe, where Westerners were first experimenting with tobacco and starting to imbibe it, or maybe a generation into it. I don't think it would have been arbitrary to say maybe this causes ill health effect. I do think it would have been arbitrary to seize on one particular ill health effect and say maybe it causes that. So I think maybe this causes cancer would have been an arbitrary thing back then. Maybe it's not good for you, I think would have been a quite reasonable hypothesis then. And then if you noticed that cancer incidence rose around the time people started doing it, which probably they didn't because people were probably dying very early anyway, but and you already had maybe this is not a healthy lifestyle choice, then putting those two things together, you would get a reason to think, well, maybe smoking is a cause of cancer. Now, I think there are two ways to think of the arbitrary. The arbitrary qua arbitrary is that asserted in defiance of the need for evidence. So it's not just that there's no evidence for it, but for a proposition to be arbitrary is for it to be taken as knowledge or taken as a hypothesis on the attitude evidence who needs it. So a proposition comes to be arbitrary when it's accepted without evidence. So long as it's unprocessed content or something that just occurred to you or something that you heard, it's not arbitrary yet in your mind because it's not being asserted. But then the question of levels and rising to the level of possibility amounts to what counts as evidence sufficient to warrant considering something. And something is possible when it has some evidence, a reason to be worth taking it into consideration. Something could have less evidence than that. And that thing would count as arbitrary insofar as one asserted it with less evidence than it needs to be worth asserting or to be worth considering as a possibility. Now, what do we mean by less evidence, and how can you even quantify evidence? It's not, when we put it on a scale of 1 to 100, it sounds like the evidence is there quantitatively, and there's an easy way to enumerate how much evidence you have, which in some fields it is possible to do that, but I think in most situations it's not. What I think usually is going on in these kinds of cases is there's evidence for something much more general, and you jump from the quite general thing to a very specific claim. So you walk into a room and you see a guy with a knife through his heart and lying on the floor and bled out, and that's certain evidence that there's been a murder and that there was a murderer. But you jump to John did it, I've always hated John, and there's no further reason to associate it with John than that. That would be an arbitrary accusation of John. There's evidence that there is some murderer, but there's no evidence that would lead you to focus in on John as the murderer. Likewise, there's evidence that if, say, more and more people are getting cancer, there's evidence that there's some cause of the increased incidence of cancer. But it might be arbitrary to immediately attribute it, even as a possibility, to this or that change. You have to think about how much evidence is needed to pick out a certain cause when you have evidence of some causal effect. And that's one kind of case. But I think often what's going on when we say there's not enough evidence and someone asserts it's risen to the level of possibility, it is we have evidence for something quite general, and then at a certain point we're in a position to formulate and credit a more specific hypothesis. And people sometimes jump the gun on that, and there's a question of when it's reasonable to do it. There might be other ways in which it happens, that hypotheses come up prematurely, but that's the one that I can think of the most things that seem to me like cases of. Again, we could see it in the smoking case from way back at the beginning. This is the stuff that makes you cough when you first breathe it in, and it smells weird, and people haven't always been breathing it in, and it burns a little bit, so there's reason to think maybe it does you some harm to breathe this in for a long time. That's, I think, at the level of possibility from right then. I think it would be arbitrary to seize on some particular harm that you at this point have no idea how it's caused and say, maybe it'll cause you to go mad, like to grow hair on your feet or something like that.
I want to ask a little more about the arbitrary. So, the way you described it a minute ago was that it's in defiance of the need for evidence. Mm-hmm. Is that your phraseology? Yeah. So, if somebody noticed all these things about smoking and said, maybe it causes cancer, right? Isn't there maybe a qualifier? So it's not like they're saying, I don't need any evidence, I'm going to say. Because I have trouble thinking of an instance of an arbitrary claim that somebody would actually, in seriousness, push forward that's not, blatantly religious or something.
Well,
It doesn't sound, the example you gave doesn't sound like a defiance.
one of the important points about the arbitrary, though, and part of what I was taking as context here, but I didn't make it explicit, is that you can put something forward as a possibility in defiance of the need for evidence to take it seriously as a possibility. Here's a kind of standard example. Maybe you fired a rocket from the Gaza Strip into Israel 2 nights ago. There were such rockets fired. I'm not saying for sure it's you, just maybe. You're a suspect. And I should be, are you part of Hamas or what's going on? And I don't know that you are, and I'm not making any libelous or incendiary claims. But just maybe you're, one of the people, and I should alert the IDF and tell them there's this guy over my place, and maybe he was one of the. After all, it could be. I think to do that maybe is arbitrary. What it means to say that maybe such and such is what the maybe is doing is saying I'm not sure of this. I'm not even saying this is the most likely of the things I'm considering, but this is something that's worth taking seriously and pursuing as an option, as a theory. This is a theory that's got something going for it. This is a hypothesis that is valid as a hypothesis. And some evidence is required for something to be a valid hypothesis, as opposed to, as Harry put it, something you just dreamed up. And that hypothesis is arbitrary. It doesn't have the things that would make it valid as a hypothesis. We can start to think about what would make it valid. You came here with a suitcase. There was a lot of sand on the suitcase and an incredible amount of soot. Your passport tumbled out, and it had, the jihadi literature, and then we could start to come up with things where then how to fire rockets with, and then I saw someone who looked like you when on the news, and we could come up with situations in which there would be reason to take this seriously, and in effect, you're counterfeiting being in that mental state when you say maybe you fired a rocket when you don't have that. You're asserting the maybe in defiance of the need for the kinds of evidence that would justify the maybe.
This comes up all the time in environmentalist claims, like fracking may pollute the groundwater, or nuclear waste stored in the Yucca Flat Mountains underneath might get so hot, something might happen that would allow it to leach out in 50 or 100 or 10,000 years?
I guess I was thinking of defiance as more active and explicit defiance of the need for evidence. Somebody is just tossing off maybes.
Well, that is just tossing off.
But then you say to them, well, yeah, what about this? And they say, oh, okay. But somebody who's in defiance of evidence would say, well, no, it doesn't matter. I don't need to answer that question.
You mean explicitly, defiantly arbitrary on principle, right? Not disguising it.
Somebody who says, I believe there's a God, why? Well, I have faith, and then you give them an argument. They say, no, I don't need arguments, I have my faith. So that's my model of defiance. I don't need damn arguments or...
But that is what someone's saying when they just assert a maybe out of the blue with no support. So, take Descartes, maybe there's an evil demon, or the modern versions, maybe I'm a brain in the vat, or maybe I'm a character in the Matrix. Ask any philosopher who raises those skeptical scenarios why they regard the scenarios as possible. Ask them for the arguments that these scenarios are really things that may be the case, and that, therefore, that you would have to rule out to be certain you had knowledge. The answer you get if you do that is basically, we don't need no stinking arguments. They just think they're entitled to just assert those maybes, and it's not really any different than the person with faith thinking he's entitled to just assert his faith. Now, all right, in some cases the people, either the skeptics or whomever, might not be as defiant about it in the way that some religious people are about faith, in the sense of they don't have that aggressiveness or militancy. But that's because the aggressiveness or militancy really only comes up when someone's been put on the defensive about an issue where they're holding something arbitrarily. Someone who's unreflectively going by faith, or who's unreflectively entertaining arbitrary, skeptical scenarios without having been challenged about it, might lack that militancy. And so if the word defiance, rings to you with too much of that militant connotation, maybe a better word, maybe some other word would do the job better. You could say that the arbitrary is that which is considered in disregard of the need for evidence, although that's a little less colorful. The point, though, whatever word we pick, the point that I'm trying to make is that an arbitrary claim isn't just a claim that lacks evidence. It's a claim that, despite lacking evidence, is treated in the way that only claims with evidence deserve to be treated. Specifically, it's regarded as a genuine possibility, as a hypothesis, rather than as a flight of fancy. The concept arbitrary doesn't apply to a proposition as such, but to the proposition insofar as it has been admitted into the realm of cognition. What the concept denotes is the fact that the proposition was admitted into the realm of cognition without satisfying the standards of the realm. So, metaphorically, we could put it this way. To be arbitrary is to be an illegal alien in the cognitive realm. An arbitrary claim either entered illegally without evidence in the first place, or else it stayed there after its visas expired, that is, after the arguments for it have been refuted. I don't really like that analogy because I don't agree with the politics of it. I mean, almost all the people who are actually illegal aliens in America ought to be legal. But, you get the point I'm trying to make with it. I suppose we could say that the arbitrary is a trespasser in the realm of cognition, but that's a less good analogy because there's not a set of standing laws governing who you admit into your property, whereas there is a set of laws, bad ones unfortunately, about who gets into the country. In any case, the point here is that to be arbitrary is, again, not just to lack evidence, but to be treated in the way that only evidenced things should, despite lacking evidence. And the way that only evidenced things should be treated is as genuine cognitions, as something that may be true, that you're taking account of in your thinking, rather than just dismissing or treating as a fantasy.
A question about assessing the objectivity of the expert. And I have a doctor example. The doctors have limited time. If you had a pain in your ear and the doctor said you have a ear infection, here's my prescription, put these drops in a few times a day, in a week it'll go away, and you want to have him spend half an hour explaining the evidence he has that particular bacteria was the cause of the infection and why this medicine has been proven to cure it, he could probably, I would argue that it's the severity of the problem doesn't warrant his spending very much time explaining things to you about that, given his expertise simply, and you feel the pain, his telling you that here was the cause of the problem, here's the cure, the remedy, is probably sufficient, versus if he said, you have lung cancer, I have to do major surgery, or you need triple bypass surgery. The consequences there are so severe, he is obligated to answer questions over a much longer period of time. So the point I'm making is that in assessing the objectivity, you have to take his context into account and ask objectively how much time is warranted for him to spend answering questions you may have at a certain level of detail. Would you not agree?
More or less. Certainly if we're talking about how much time is warranted. Now this is complicated by the fact that we don't have doctors who are people we hire to spend their time. If our whole relationship with doctors is skewed, and their way of looking at us is skewed by the fact that they're, in effect, civil servants obligated to meet certain quotas, rather than you being their customer, buying their wares, and so that
understood.
further complicates things. But if a doctor just said to me, you have an ear infection, take this drop, I wouldn't be happy with that. And there are plenty of things he could do that I think is more likely that a doctor would do. That would take no more time than that. I would be much more happy with a doctor that said, that sounds like an ear infection. They're very common. This drop would help with most ear infections. Try taking that. That's quite different than all there's a sense of that he's not entirely sure, but this is a likely thing, or some indication of why it is. And in my experience, that's what doctors have usually done. Evan never came in and they handed me a pill and said, take this. And if a doctor did do that, I'd want a different doctor. Even for something trivial. Sorry.
I didn't find the case well, but but it wouldn't be warranted for you to consume very much of his time for what was in fact a trivial illness. Versus,
it also wouldn't be worth your spending very much of your time for what's
yes.
a trivial illness.
That's what it is.
So, as I said in the other talk, you have to decide how much work it's necessary to do to get how sure about things based on how important it is to know those things for you. If the stakes are pretty low, then the doctor is a real doctor. Doctors know how to tell this kind of stuff. It's probably true that this is what's causing it and this will fix it. His reason was that that's the most common cause of this symptom, and that's plenty fine. But I think that is what you would get in the kinds of conversation that we were talking about. Yeah.
I wanted to get on the subject of assessing the legitimacy of a field. So there are two things that I like to do, and I'm curious what you think of them. One is something I think is neglected very frequently, which is before you even get into a particular claim, generally, I mean, fields are founded around a central theory or a central question or a problem, and getting a sense of, and some of these things require cognate knowledge depending on what field it is, and it'll probably be different for different problems, different fields. But getting a sense of how difficult inherently that problem is to solve. Mm-hmm. I find a lot of people just think, okay, this group of experts is doing X, and this other group of experts is doing Y, and they just conceptualize it as they're just experts, and it's just a problem, and they're trying to solve it, and they kind of accord the same default kind of likeliness or likelihood that this group will solve this problem and this other group will solve that problem, when certain problems are just orders of magnitude more difficult than other problems. So that's one thing. And the other thing is, and this will be, in some kinds of fields, it'll be more applicable than others, but generally, even though if you're not an expert in a field, and frequently if you don't have special educatedness in that field, there are still things that certain fields produce, achievements that they produce that are just almost self-evident in kind of demonstrating that there's something right going on in that field. You launch a rocket ship to the moon or something. I mean, that clearly, you don't have to know a lot about electronics or engineering to know these guys really have done something powerful, and there's something really special behind what they've achieved, and they claim this body of knowledge, and that certainly confers a lot of likelihood on the value of that knowledge. And there are tons of examples of this, these solid-state physicists have built this transistor, and we have all these computers. I don't have to know anything about solid-state physics to know that at least that confers more evidence on the likelihood, on the claim that solid-state physics is doing something legitimate, or just modern physics in general. So I'm curious what you think of those kind of heuristics.
I agree with both of those. The second one I appealed to earlier when we were talking about the F equals MA. So that one I think is specialized achievements by people. You couldn't match the achievement. Most people can't. They tell you it's based on a certain body of knowledge. That doesn't show you that there aren't a lot of wrong things mixed in with that body of knowledge. It doesn't show you they're all aces, but it does show you that there's something there. It's nothing to scoff at. You should think about why it is, and it can thereby confers quite a bit of status onto it. The other one, I hadn't thought of in quite those terms, how difficult the problem is to solve. I would want to add, generalize it a little bit. And I'd also want to add something to look at before that. This seemed to me to go in a certain order. You started with what's the initial premise of the science or problem it started to solve. Before asking how difficult is it to solve, I'd want to ask, is it a legitimate problem in the first place? Is there a reason to think there's a unified body of phenomena here that needs to be explained or not? So, for example, if the science is interested in studying the problem of how does the positions of the planets at the time of our birth relate to our personality later in life, before I'd even ask how difficult the problem or what's involved in solving that, I'd want to know what reason is there to suppose that there's any relationship between those two things such that it's worth investigating them. And you might say, well, what's the problem with that? Just whether or not there's any reason. These people say they investigated it, and you could think that you put that all under how hard it would be to show that it's true. But I don't think that's right. I think it's a distinct step. Is there any reason to have begun this enterprise? As opposed to some more general enterprise, which might be legitimate, like figuring out what things are factors in a person's personality. And if you had a science doing that, and then you noticed surprising correlations between the personalities of people born in certain months, and you thought, well, it had to do with other factors, but you were somehow able to control for what the weather was like and everything else, and it seemed that all that was left was the star. It's hard to even imagine what it would be, but something that might make one start to consider rationally that as an influence. I can't even really come up with this case, but I want to know why they even got into this line of it. Why did this question come up for them? Why did they think it was a question that was legitimate in the first place? Particularly if it's an explanatory question. An explanatory question requires an explanandum, and you have to know the explanandum is true, or at least probably true, before there's any legitimacy to looking for an explanand for it, looking for what would explain it. So first is, why do they think there is something here that there's an answer worth looking for? Why do they think that there's a phenomenon to be explained or to be looked into? Then yours was, how difficult is it to solve that problem? See, that puts it in terms of there being a discrete problem, which I don't think is usually how fields work, or it's not how I think of fields. So I would think of it as, what kinds of work would be involved in getting explanations in this area? But I think that amounts to the same kind of thing, and what would be involved to have this sort of knowledge. So I would also, in addition to the quantitative, how much work is being involved, I would want to think about also what sorts of work would I expect to be involved in it. And not think of it as just a single thing that's sought, but also, think of it as a set of questions rather than one. But I think these are not very big differences from how you're thinking of it.
There certainly are fields that are kind of based around a central problem. I'm thinking of climate science. The problem being predicting what the climate's going to be like 100 years from now.
But just there, I think that's a problem with the field. That is, I don't think there's any legitimacy to a field, if that is what they're doing, that's purpose is to figure out what the climate is 100 years from now, or a field that's purpose is to figure out what the effects of fossil fuels on the climate are, or something like that. The legitimate field would be one that was interested in what are the drivers of climatological trends over time, or something like that, which is a bigger, and what factors go in, which is a little bit, it's not as narrow a question as what will the climate be in 50 years from now if we keep using CO2.
Yeah, and backing that up, finance and stock market prediction is a valid field, and they can identify a lot of variables that go into affecting stock prices and valuation, but they can't predict what the market will be 100 years from now. That would be an insoluble problem. Of course, there's free will there.
But that's a different issue in the sense that weather is different than climate. So I think the predicting where the stock market would be in 100 years would be equivalent to predicting the weather. And that's not what...
No, predicting average.
Okay.
The Dow Jones average would be like the global average.
Well, actually, I think that is a very soluble problem, because if you take a log plot of the Dow Jones, it's actually, relative to gold, say, or something.
I would bet to make you after.
Okay, I'm just saying, I think that would be a legitimate field for kind of like future scientists. I don't know what you want to call them, but it's not.
If you made some assumptions about how the economy was growing over time, and you took into account inflation by denominating it in the price of gold.
Right. I'm not saying I have the answer to that. I'm just saying it's not. It doesn't seem totally arbitrary to me.
It does to me.
Okay.
Then it's the attempt to predict long-term economic trends. I mean, that's what we're really talking about, or long-term economic growth. See, I don't think any science, I might be wrong about this, but anything that deserves to be called a science is about one very determinate question. It's about organizing knowledge of a kind of thing and developing more and more.
Maybe I should clarify. So I kind of meant the spark or the motivation that causes a field to come into existence. I mean, once it's a more mature field and has a whole body of knowledge to organize, I agree. It seems kind of silly to define it around one particular, very concrete question or practical motivation. But I mean, I think that is not unusual to be the process by which a field kind of nucleates from other similar disciplines.
But I would think, this would be a really good question for the history of science and things like that, but I would think that part of what's involved in its becoming a legitimate field, developing a methodology, developing an objective, non-arbitrary, rational research agenda, is identifying a broader area of concern rather than fixating on a narrow question, especially if it's a yes or no question, or a how to accomplish something. So take alchemy versus chemistry. Now, it's not really literally true that alchemy was just about turning lead into gold, but for simplification's sake, take it that way. There was no reason to think you could turn lead into gold in particular. It was not something that should be regarded as possible. Now, maybe it should have been regarded as possible to transform chemicals into one another. And a reasonable line of research would have been what things can be transformed into what other things, what principles govern that, and what uses can be found in it. That's quite a different thing than it's can we and by what means transform lead specifically into gold. Now, it might be that the thing that got you thinking about this line of question is, I wonder if one could transform lead into gold. But I think so long as one's focused on that specific case, one's actually pursuing something arbitrary and in a non-rational manner. If a kind of ruminating about that and a debate among friends about that starts out this more general way of thinking, and it serves as a kind of paradigm case of the kind of thing it would be cool to do, but what this field is really about is not that specific thing, but transforming things into one another and understanding the principles of transformation, and this is held off as a kind of, concretization of that ambition, but it's not really what the field is about, then that's something quite different. So likewise, if somebody noticed that a lot of stuff was being pumped into the atmosphere by smokestacks and said, wow, there's a lot of stuff being pumped into the atmosphere by smokestacks. I know from geology that even small changes can have big effects over time. That, and I know from other fields that, when a new species is introduced, it could radically change a landscape over time. But think of the way the coral reefs were built and how much that changed the ocean and so forth. Here's an interesting thing human beings are doing, putting a certain amount of CO2 into the air much more than before. That's the kind of thing that could have big effects. I wonder what the effects are. That's a good question. And now you can start asking it within the context of established knowledge about the climate and the effects of things on the climate. If it turns out that there isn't enough of a body of knowledge about the climate yet to solve that question, and that to answer that question, you would need a whole science of climate science that understood all the drivers of climate change, and no one knows that yet, then I think that question, and you're wondering about that question, could be a good impetus towards developing the field of climate science. But if you develop the field as a means now to solving the question of what are the effects of smokestacks on the world, that is going to severely prejudice the field. In the same way that if everything that was done with chemistry was in service of making gold from lead, I don't think chemistry would have ever gotten anywhere. And I think there's a reason to worry that is in fact what happened with climate science. And that's one of the reasons why I think of it as a dubious field. Thinking of it as a dubious field doesn't mean thinking there's no knowledge anywhere within the field, maybe not even important findings, but there's something weird and prejudicial about the organization of this whole pursuit that is the kind of thing that would drive wrong theories coming to the fore, or at least not make me confident that correct ones would tie things to recommendations for action before they're mature enough as theories to properly get so tied, and so forth and so on. And it's, I think, a real reason to be suspicious of the field, precisely that one question plays such a big role in it. It would be fine if that one question sparked the field, and then somebody in trying to research it realized we didn't have enough information to solve it, and what we would need is a whole theory of climate, and then went to work on developing one, and maybe always held in the back of his mind, I wonder how this will go back to my... But that's not the center of his agenda. And again, I don't really know so much how the actual field of climate science works. And maybe the more optimistic thing is true of the best people in the field, and in which case it's a better science than I'm thinking. But I think that distinction between the two is important, and it's related to some of the issues about when something counts as possible and the abstractness at which one needs to formulate questions. Is climate driven by human output of CO2 is far too concrete a question for a science. Or what role does human output of CO2 play is far too concrete a question. You want a more general question like what things cause large-scale changes in the climate over time, and then within the context of a science about that more general thing, you can then answer this specific question. Okay, well, thanks everyone for coming and for some really good conversation, and I hope to see all of you guys again soon, and for people on the tape, I hope to see all of you at some future OCON. Bye-bye.